This is BBC Bite Size with Chris Smith and with Dave Ansell. We're from The Naked Scientists. In this podcast, we're looking at nuclear energy. So, Dave, what is the basis of nuclear power?
It's a way of extracting energy from the nuclei of atoms. An atom's nucleus is a dense part at the centre of an atom, made up of protons and neutrons, and surrounded by a cloud of electrons. You can get energy from atomic nuclei in two main ways, nuclear fission and nuclear fusion.
OK, let's look at the first of those. How does nuclear fission work then?
Fission is another word for splitting things up. It involves breaking up the nuclei of large elements such as uranium and plutonium to form much smaller ones. This process releases a huge amount of energy in the form of heat, which you can then use to run a power station.
But how do you make the large atoms split up in the first place to release energy like that?
First, you have to pick an atom which is unstable in the right way, such as uranium-235 or plutonium-239. If a neutron hits the nucleus of one of these atoms, it can trigger the atom to split in two. This releases a huge amount of energy because the two halves of the nucleus are both very positively charged. They repel and fly apart incredibly fast. As well as the two halves of the atom, these elements also spit out 2 or 3 more neutrons.
And those neutrons presumably can then make other atoms split?
Yes, if they hit another nucleus, they can. So one atom that splits can release enough neutrons to split another 2 or 3, which in turn can each release 2 or 3 neutrons. So in each generation, more and more atoms will split and release energy. We call this a chain reaction.
And will that keep going forever?
A nuclear reactor is very carefully designed, so you'll only get a certain rate of reaction and no more. But if you design the system in a different way, then the chain reaction can get bigger and bigger and bigger. You get an immense amount of energy released very quickly. This is a nuclear explosion. You have a nuclear bomb which can release energies equivalent to millions of tons of TNT exploding all at once. Although even more powerful bombs can use nuclear fusion.
And how does nuclear fusion differ from the nuclear fission process?
Well, fusing things means sticking them together. So nuclear fusion means sticking light atomic nuclei together, which can also release an immense amount of energy.
But how do you do that? How do you make two nuclei stick together?
First, you pick a really light nucleus, such as an isotope of hydrogen. You then have to get the light nuclei very close together, so they'll actually stick, and then they can release this huge amount of energy. The problem is that all nuclei are positively charged, so they repel each other very strongly, making it very difficult to get them close enough together in order to fuse.
So how do you do it then?
Basically involves giving the nuclei enough energy to overcome the repulsion by making them very hot, then trying to get them to collide with one another. However, it's very difficult to give nuclei enough energy and get them close enough together at the same time so they react. Scientists try to trap them magnetically or just by heating them so fast their inertia doesn't give them enough time to escape. In fact, the only nuclear fusion reactors that work really well are stars.
So how do stars do it when we can't?
A star is a huge ball of extremely hot gas held together by gravity, which has enough energy to fuse hydrogen atoms into helium. Luckily for us, this happens very slowly over billions of years, so the sun is still running after 5 billion years. Nuclear fusion is what powers the sun, and therefore indirectly almost all living things on Earth.